Next question. An equiconvex lens of focal length 15 cm is cut into two equal halves in thickness. What is the focal length of each half? So first draw the diagram of convex lens. This is the convex lens whose focal length is given 15 cm. Then it is cut into two equal parts. Let this is one part and this is another part. So in the question it is given focal length of convex lens f is given 15 cm. Then the lens is cut into two equal parts and we have to find out the focal length of each part. So here we have to use lens maker's formula. What is lens maker's formula? That is 1 divided by f, that is equals to mu minus 1 multiplied by 1 divided by r1 minus 1 divided by r2, where f is the focal length of the lens that is given 15 cm and mu is the refractive index of the lens, and r1 and r2 are the radius of curvature of the first surface and second surface. And you know, for a convex lens, the radius of curvature of the first surface, this is the first surface, and here r1, the radius of curvature will be positive because both the center of curvature and the focus, they lies right to the optical center. So for first surface you can take the radius of curvature is positive, this is r, and for second surface both center of curvature and focus, they lies left to the optical center. So by using sign convention they will be negative, and you can write r2 that is minus r. Then use r1 and r2 in this equation. It will be 1 divided by f, that is mu minus 1 multiplied by 1 divided by r minus 1 divided by minus r. So that is mu minus 1 into 1 divided by r plus 1 divided by r, that is mu minus 1 into 2 divided by r. That implies f will be equals to r divided by 2 into mu minus 1, which is given 15 cm in the question. Then this lens is cut into two equal parts. When cut into two equal parts, these are the two equal parts. Here also we have to use lens maker's formula, 1 divided by f. Let for the first surface the focal length is f1, or second surface the focal length is f2, and both equal, so you can write f1, that is equals to mu minus 1 into 1 divided by r1 minus 1 divided by r2. Clear? r1, for both the parts the radius of curvature, first radius of curvature will be r, because the center of curvature and focus both lies right to the optical center. So here r1 that is equals to r, here also r1 is equals to r. And for the second surface, this is a plane surface. For the plane surface the radius of curvature is infinite, So here R2 will be infinite, here R2 will be infinite. So the focal length will be mu minus 1 into 1 divided by R minus 1 divided by infinite. So 1 divided by infinite, that is 0. So this will be equals to mu minus 1 divided by R. That implies F1 will be equals to R divided by mu minus 1. So what is the value of R divided by mu minus 1? So from this equation, R divided by mu minus 1 will be equals to 15 into 2, that is 30 centimeter. Then the focal length of the two parts will be equals to 30 centimeter. This is the answer. The focal length of each half is 30 centimeter. Answer. This is the answer.